here. So as you know, transistor is a tiny equipment. It's a small equipment, just the shape of your thumb or tip of your finger. It's just a small equipment. Whenever we are discussing about configuration, transistor can be connected in three ways. Assume this as a breadboard, this green color as a breadboard. What I am doing, we are connecting a transistor in three ways. The three terminals of transistor, what are the three terminals of the transistor? Emitter, base, collector. Assume this emitter, base, collector. Whenever you are connecting a transistor onto the breadboard, you can connect transistor in three ways, three fashion. Those are nothing but common base configuration, common emitter configuration, common collector configuration. Now what do we know common? Just look at here. Consider this as emitter, this as base, this as collector. I am telling that common base. The whatever the terminal I am referring it as common, that will be grounded. That will be given as 0. Whatever the remaining terminals left, emitter and collector. One terminal will act as the input, another terminal will act as the output. Like this, transistor can be connected in three ways. If I say common emitter, emitter will be grounded. What are the two terminals left? Base and collector. Collector will be output, base will be input. If I say common collector, which terminal is grounded? Collector terminal will be grounded. Other two terminals will act as, one terminal will act as the input, other terminal, second terminal will act as the output terminal. Understandable? I will draw the diagram, I will give a hint, I will give a basic information. No need to by heart the diagram. The circuit will look complex, though I will make it easier how to draw common base configuration circuit implementation diagram. Just follow it. So first what we will do, we will draw the symbol. We will draw the symbol of the transistor. If you want to practice it roughly, you can draw this. Don't discuss reason here. So first what you do, you draw the symbol of the transistor. If you are going from common base, the symbol should be horizontal. So diagram your symbol should be horizontal. Apart from others, common emitter and common collector, so your symbol should be vertical. So this is horizontal symbol of the transistor. And I am telling that common base. So consider this as base. Consider this as emitter and consider this as collector. Keep in mind always your input will be at the left side of your diagram and output will be at the right side of your diagram. I am telling that common base. So base is grounded. First you do this. This is the basic step. This is the basic thing. And the mostly used transistor is NPN transistor. What? Which is the most used transistor? NPN. So you need to, for your understanding purpose, write down N here, P here, and N here. This will become NPN. So you can connect the proper polarities. You can connect the proper potential. For that purpose, for your understanding purpose, write down NPN. A small font size. Don't make it as bigger. Make these numbers bigger, E, B, C. These font size should be smaller for a better understanding. So this is the first step. Now we are discussing about input and output CAD. Now in order to do a circuit implementation, in order to do practical experiments, what I will do, I will connect an ammeter here at the input side and a voltmeter here at the input side, an emitter and a voltmeter. Understandable? Because we are doing this, we are studying this characteristics practically. This we are doing in the lab. Connect an ammeter, connect a voltmeter at the input side. Same thing, connect an ammeter at the output side and a voltmeter at the output side. Join them. Understandable up to this? Yes, sir. So you give a name to them. So this will be emitter current, and this will be collector current, and this will be base current. And you can name them. Name as voltmeter. Give a name VEB, and give a certain name to this VCB. Understandable up to this? Say sir. So we are doing practically this experiment. That's why we are studying about input and output characteristics. So we are connecting an ammeter at the input side, a voltmeter at the input side. Whatever in the diagram which is available at the left side, that is your input. Whatever which is available at your right side, that is your output. Keep in mind, in every diagram, left side is input, right side is your output. Understood up to this? Say sir. Now what I will do, in order to protect my equipment, I will connect what is this? What is the symbol of this? What is the symbol of this? Resistance. I will see decayed resistance box in BWE. So if you put an arrow mark to across a resistor, that will become variable resistance. If I won't put this arrow mark, it is simply a resistance. Simply a resistance means fixed resistance, 10 kilo ohm, 1 kilo ohm, whatever it is. If I put a arrow mark, you can vary that resistance from 0 to 10 kilo ohm. Understandable? So I am connecting a decayed resistance box here. And what about this? I will ask you questions based on that. I am keeping that as empty. So here also I will connect a decayed resistance box. Just see your diagram. I hope here also we have a decayed resistance box. Okay. Now there are two statements. In order to understand the concept thoroughly, in order to understand the concept from third unit, I have given already two statements. Anyone from the class? Do you remember them? In order to understand the topic properly, in order to understand whole complete third unit, there are two statements that are very important. Let me revise you because you guys are still in vacation handover. Let me remind you, how many junctions does this transistor has? How many junctions? 2. This is J1 and this is J2. Junction 1, junction 2. How many terminals? 3 terminals. Emitter, base, collector. The transistor, NPN transistor has 3 terminals, 2 junctions. A common PN junction will have only 1 junction. Say sir. Now in NPN transistor, how current will flow? Base to emitter. Someone is saying those are the two important statements. Always keep in mind, always emitter base junction is forward bias. Always collector, that's why I wrote it as VCB. This is what? Collector base. This junction is always reverse bias. Always, I'm giving a statement. Always EB is forward bias. Always CB is reverse. Now this is N terminal. N means negative. P means positive. Now what polarity will connect here to make it as forward bias? This end what will connect? Negative. Say sir, negative. Negative to the negative, positive to the positive. That makes EB as forward bias. So I will connect negative, positive, negative, positive. This is the source. Keep in mind, this is source. This is not a battery. Say sir, this is the source, minus plus. So this is nothing but RPS. Have you seen regulated power supply in your BW lab? That will give 0 to 10 volt. That you can vary. That you can keep it as fixed. Why we are connecting this source? Who is the natural source for light? Sun. But this room I want light. What will do? We'll use tube light. Now I want to run this application. That's why I am connecting this regulated power supply. I want to make transistor as working condition. Understandable? You need to name it. Don't keep it as empty. You need to name this as V. This is a certain voltage, and what terminal it is Z. Make it as V double E. Understandable? V double E. Then what it is? Here what you connect in order to make CB reverse? So positive, negative to the positive, positive to the negative. Positive, negative. This is somewhat bigger. Okay. Understandable? So this will become what? VC. That is collector and this is the circuit implementation. No need to buy anything. Understandable? Say sir. Keep in mind, emitter base junction is always forward bias, collector base junction is always reverse. Based on that only you are connecting these polarities. Clear? Say so. Understood? So I hope you have understood completely. Now what is our heading? Read it completely. Input and now let me explain you what are the input characteristics are there. Let me explain you. Keep in mind, characteristics means you are drawing something, you are drawing a graph. Keep in mind, characteristics means you are drawing certain graph. Input characteristics. So what graph I have drawn? On x-axis what it is? On x-axis VEB. On y-axis what I have? I. Listen here. Listen carefully. In order to study about input characteristics, focus properly. What I am telling? Input characteristics. So whatever the parameters are available at the input side, that you will change, that you will vary. What parameters are available at the input side? VEB and I. This is nothing but I. Ammeter means the current or the ammeter is where it is connected at? Which terminal? Ammeter. The ammeter, this is ammeter, this is ammeter. The current which is flowing in the ammeter will be denoted as I. What it is? VEB. Now we are studying input characteristics. Whatever the parameters are available at the input side, that will change, that will vary. Whatever the parameters are available at the output side, that will keep it as constant. Understandable? We are studying about input characteristics. The parameters which are available at the input side, I will change. I will change VEB. What is available on x-axis? V. I will change VEB in steps of certain one. 0.1, 0.2, 0.3, 0.4. I will note down. I will see what is happening in IE. Understandable? I will note down on y-axis. I will keep this as constant. I will keep VCB is equal to 0 volts. This is first case. If this is 0, what about this? 0. V is equal to IR. Voltage is directly proportional to current. This is my first case. Now, anybody in the class, what will happen here? What will happen to IE current? If I goes on changing the voltage in steps of 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, 1 volt, what will happen to emitter current? increases. Why? Because EB is in forward bias. Emitter base junction, that junction will behave like a PN junction diode under forward bias. So your current will increases rapidly. What is this? This is the graph for PN junction diode under forward bias. So your current will increases rapidly at a certain voltage. Now this is the case. VCB is equal to 0 volt. This is the first case. In second case, what I will do, I will make VCB greater than 1 volt. Again, I will repeat the same step. I will vary VEB and I will note down IE. Here, what will happen? Let me tell you. This graph will shift towards the left side for VCB greater than 1 volt. Because for lesser value of VEB, you will get a maximum increase or you will get a current will increases rapidly. Understandable? VCB is greater than 1. You are varying VEB. For a lesser value of VEB only, your current will increases rapidly. What I am going to tell you is that this graph will shift towards left side. Clear? Understandable input characteristics? Keep in mind the heading itself, subheading itself telling you input characteristics. Whatever the parameters are available at the input side, that you will change, that you will vary. Whatever the parameters are available at the output side, that will keep it as what? Constant. Constant means fixed value. First case 0. You will change VEB and you will note down I. As EB, emitter base junction, is forward bias, you will get a maximum current. Current increases rapidly. My second case is I will make VCB greater than 1 volt. Again I will repeat this step 0.1, 0.2, 0.3, 0.4, 0.5, 0.6. I will note down IE current. That will increase suddenly for a lesser values of VEB. Understandable? If you do practically, definitely you will get these kind of values. Nearly these kind of values. I in milliampere, VEB in volts. Clear? Yes, sir? Yes, sir. Understandable? Okay. Now let me move to the next subtopic. What is that? Output characteristics of common base quantity. Then what do you do for output characteristics? What do you study? How will you study output characteristics? Vice versa of this. What do you do? Whatever the parameters are available at the output, that you will vary, that you will change. Whatever the parameters are available at the input side, that you will keep it as constant. So let me draw the diagram for that. Shall I erase this? Shall I rub this? Or you guys have already noticed. I'll rub this. So what is the y-axis? VCB. What is the y-axis? VCB. That is in terms of voltage. What is the y-axis? X-axis? VCB. On x-axis what it is? VCB, connected to base voltage. On y-axis, collector current. focus here. I hope you have the circuit diagram. So, in order to study output characteristics, we will vary the output parameters, we will vary VCB in steps of equal voltage 1, 2, 3, 4, 5, 6, 7, 8, and we will note down what? What is note down? Collector current. What is available on y-axis? Collector current. But in this case, what do you do? First case, focus here. I is equal to 0 milliamp. You are keeping input parameter constant. Say yes or no? We are keeping input parameter constant. If I want to make I is equal to 0, my first case, then what will be VEP? 0 only. Say yes or no? If it is 0, this will be 0. Fixed value. Once you keep it as 0, you should not touch those ammeter and voltmeter. What you will touch? You will vary VCB. You will see, you will note down IC. Understandable? My first case is I is equal to 0 milliamp and I am varying VCB and I am noting down IC. Say some understandable? So these are the values I will tell you. Now second case, I will change I is equal to 10 milliamp. Again I will vary VCB in steps of 1, 2, 3, 4, 5 and I will note down IC. Third case, I is equal to 20 milliamp. Again I will repeat this step. I will vary VCB in steps of 1, 2, 3, 4, 5. I will note down IC. Fourth case, I is equal to, don't look into your mobile. Look at your concentrating. Third case, I is equal to 30. Fourth case, I is equal to 40, 50. Fixed values. Understandable? What you are varying? VCB and you are noting down IC. So here what is happening here? These curves, I am not telling line, these curves are parallel to VCB. If you increase VCB, IC is constant. These curves are parallel to VCB. Look at here, I am varying VCB 1, my IC is here. I am varying VCB as 2, IC is here only, it is not changing. This is not that kind of graph, that kind of linear graph. IC values are constant only. For I is equal to 10, my IC is 10 microampere, 10 micro, 10 only. Even if you are varying VCB, 10, 10, here 20, 20, 20, 20, here 30, 30, 30, 30. These curves are parallel to VCB. Means IC is not dependent on VCB. IC is independent of VCB. Understandable? Clear with this? Even if you are increasing VCB, IC is not increasing. It is constant. It is constant. These curves, these are parallel to VCB. Clear? Say so?
Yes, sir.
So there are three regions: saturation region, active region, cutoff region. I will explain you further configuration what do you mean by them. Understood with this? Clear? Say sir. Let me remind you one more time. In order to study input characteristics, you change the parameters whatever available at the input side. You will keep constant output parameters. In order to study output parameter, you change whatever the parameters available at the output side. You will keep input parameter as constant. As simple as that. Look at here one more point. Even if your VCB is 0, focus here. What I am telling? VCB at this point what it is? 0. Even though you are having IC current, some amount of IC. Even though your VCB is 0, I am having the some amount of IC. This is the reason because as emitter base junction is forward bias, some majority carriers will move from emitter to the base to collector. That is only giving rise to some collector current, minimum collector current. Though VCB is 0, 0 means I have not connected anything. You should not have a collector current. Say so. If this is 0, this should be 0. But in this case I am having the some amount of collector current. That is the reason because your EV is forward bias, some electrons, some carriers will move to emitter to the base. As base is lightly doped, it is very thin. Those move, they will move to collector. That will give a minimum amount of collector current. Though VCB is 0. That's why I drawn a graph from here. Understandable? If this is 10 microampere, this may be 5. Say some 5 and 4. In general, I am telling. Clear? Understood? Say some. Any doubts? Any queries? Same I have drawn. Whatever the notes are available, same graphs I have drawn. Why there is a question mark? Yeah, you just